In this lesson, we look at electrolysis of aqueous solutions. So in electrolysis, we've seen so far that we are splitting up an ionic compound to form the element. If you need to revisit the basics, you can look at the previous lessons because we're going to get straight into it. So the difference is now that we have an ionic compound, let's say sodium chloride, but is in aqueous solution. What this means is that now there are different ions that are present, or more ions present, because aqueous means dissolved in water. So we also have, in addition to sodium ion and chloride ion, we also have the hydrogen ion and the hydroxide ion. This is because water splits in this way to form hydrogen, or dissociate in this way, to use other word, and hydroxide ion. So these ions, they are involved in electrolysis. So we need to consider that. There are two rules that we will follow to identify the products at the anode and at the cathode. But before we look at that, we needed to remember or revise one thing, which is the reactivity series. So I'm going to write down some notes here on the reactivity series of elements. So the reactivity series, remember, is this list of elements that are of metals that are placed in order of reactivity. So we have the most reactive at the top and the least reactive at the bottom. And here is the list. We have potassium, sodium, lithium, calcium. Then we have magnesium, aluminium. I know it could be difficult to remember it, but there are some tricks that you can use mnemonics or if you know the trends in reactivity down each group, you can it can help in remembering it. In this series, we also had carbon and hydrogen. We will see why. Copper. I'm going to stick with copper. After copper, we have also silver and gold, but can't fit them in the list here. So potassium being the most reactive element or metal, and in this list we have copper being the least reactive. Hydrogen and calcium, they're present here because these help in understanding why the products are formed and why we need to do the electrolysis to extract some metals. So the two rules that you need to know, or better, the ones that are involved here, we're talking about cations because sodium and hydrogen, they're cations, so they're attracted to the cathode. So at the cathode, we would have sodium and hydrogen that move towards it. So we need to choose one product only. The rule is that at the cathode, the least reactive cation is formed in its elemental form, of course. So this is the rule that we need to use to identify the product of electrolysis of aqueous solution. So let's say that we have sodium versus hydrogen ion. We can see that the sodium, it's more reactive than hydrogen because it's up here, the series. Hydrogen is here, sodium is up here. This means that the product of this electrolysis is hydrogen. And remember that hydrogen in its elemental form, it's a hydrogen gas. So the product of this electrolysis would be the hydrogen ion, the hydrogen gas. Let's look at another example. Let's say that we have copper chloride in aqueous solutions. First of all, I would suggest you identify the ions that are present. We have copper, 2+ ion. We have chlorine, 1- ion. And then we have hydrogen and hydroxide ion because it's aqueous solution. Think for a moment, which of these ions are attracted to the cathode? Cations, so the positive one. If I ask you to identify what is the product of this what is the product at the cathode, you need to think about this rule. At the cathode, the least reactive cation is formed in its elemental form. We are comparing copper, and we're comparing hydrogen ion, versus hydrogen ion. Notice the position in the reactivity series. This time, copper is less reactive than hydrogen. So this will be formed. And it would be copper as a solid because it's a metal. So this is the product of the electrolysis if we have copper ion in this aqueous solution. We have 2 more ions though to consider. We have the hydroxide and the negative ion. Anions, they're attracted to the anode. We're looking at the same ion in this case for both electrolysis. Anions are attracted to the anode. Now, the rule is slightly different. And the rule goes this way. At the anode, oxygen gas is formed unless an halogen is present. Halogens, chlorine, ion. So, if we look at this, we have chlorine and hydroxide ion. We have an halogen, so it's chlorine that it's formed. An example of a different one would be, let's say, lead nitrate in aqueous solution. At the anode, we could have the hydroxide ion from the water and the nitrate ion from the lead. Because an halogen is not present, is oxygen that is formed. This will be the product. So as you can see, we need to apply these rules. Okay, we need to apply these rules when we have aqueous solutions. You can give it a go to this question and see if you can work out the products at each electrode, of course, of the electrolysis of aqueous copper sulfate. Pause the video and then when you're ready, play back to hear the answer. First step, let's list the ions that are present. So copper sulfate means that we have copper and sulfate in aqueous solution. So we're going to have hydrogen ion and the hydroxide ion. We need to remember the rules for the cathodes. Sorry, this is supposed to be a minus, not a positive. For the cathode cations, the least reactive cation is formed. And we will look at the reactivity series. Copper is below hydrogen. So this is the least reactive. This is going to be formed. Copper solid. Between the sulfate and the hydroxide, the rule was at the anode, oxygen is formed unless an halogen is present. So this is not an halogen, which means that oxygen will be formed. One point that I want to make is not only you need to be able to work out the products, and this could be just like 1 mark. Often you're asked about the observations at that electrode. So if you have a solid, how would that look like? Yeah, in an electrolysis. Well, the solid is actually being deposited on the electrode. So the electrode would increase in mass, or you would see the actual color of the solid forming around it. So let me write it down as like another question. What can you observe at each electrode? If you have a solid form, you would observe an increase in mass. You would also observe an actual solid on the electrode. In this case, you know, copper is like this copper color. So that's what you could mention about the color if the metal has a color that you can distinguish. While if you have a gas, remember, this is all in a solution. So at the anode, if a gas is produced, you would observe bubbles because a gas is formed. So important to know the observation, for these changes in state. Okay, I hope this is clear. The next part will be know how to write the half equations.